Okay, so it's 11 o'clock now, so we shall start. So good morning, everyone. Welcome to the second section of the Future of Software Engineering track. So this special track features presentation and discussion from invited top researchers and industry leaders. So my name is Hoa Dam. I'm from the University of Wollongong in Australia. I am a co-chair of this track. And this morning, I have the privilege of chairing this section this morning. So the section will start with 10 minutes talk from each speakers, and then it followed by a Q&A panel discussions. So if you have any questions, so please hold until the panel discussion. So this morning, we have 4 distinguished speakers. We have Professor Laurie Williams from North Carolina State University. We have Professor Gail Murphy from University of British Columbia. We have Professor Lionel Bryan from University of Luxembourg and University of Ottawa. Professor Andreas Zellers was supposed to join us today, but due to last-minute personal reasons, he's not able to attend the conference. Fortunately, we have Professor Aldeida Aleti. She has agreed to step in as a last-minute replacement. And even more awesome, the title of the talk remains the same. So Future of Software and Testing. So she will be the first speaker of today's sessions. So without further ado, I give you Professor Aldeida Aleti.
Hello, everyone. Thanks, Hao, for the introduction. I'm Aldeida from Monash University. Before I start, I would like to acknowledge the traditional owners of Naram, the Wurundjeri Wurrung people of the Kulin Nation. I pay my respects to their elders, past, present, and emerging, and to elders of all First Nation communities that are here present today. I recognize the significance of the Birrarung to traditional owners as a life source and a meeting place and part of a 40,000-year tradition of building community and exchanging ideas on these unceded lands. And if you don't know, Birrarung is the Yarra River that's just in front of us. So Andreas is not here today, and I'm not Andreas. Unfortunately, he couldn't make it, but he's well. He's tested negative, so now he's good. And I did reach out to him and ask, well, what did you want to talk about today? And he said that he wanted to talk about his ERC grant, which is in semantics of software systems. He has a video in his Twitter page, and also very generously he's made the proposal available for everyone. So I strongly recommend that you go and check his video and his proposal. But my talk today will be a bit different, although, as Hoa mentioned, in a similar area. And I'd like to advocate today for the importance of software testing in this new age of software engineering. And I know you've heard a lot today about generative AI. Maybe you don't want to hear about it anymore. We just had a keynote today about it, just recently. But in a way or another, it will impact us. And I think it's important that we think about it. And it will impact the software testing field, both in terms of how do we test these systems, but also I think there's lots of opportunities there to use these systems for improving our testing approaches. There was an interesting survey by KPMG asking developers how do they use generative AI. And in the session yesterday, in this very session yesterday, the panel members were talking about how to completely automate the different steps of software development, which is a very interesting vision, and I think wonderful. In industry, at the moment, generative AI is quite widely used in one form or another, in one level or another. And from this survey, these were the kind of things that software developers were doing with generative AI. From explaining the functionality of code to asking generative AI to simplify code, asking to explore alternative solutions, both in terms of code and architecture, asking which classes have the necessary functionality, class selection, writing code, improving consistency of code, generating unit tests, accelerating debugging, translating code from one language to another, and more other functionalities. So indeed, generative AI is already part of software development process and is helping software developers become more efficient. these generative AI-based systems are not just used by us as software engineers, but also they are finding real applications in the real world for safety and life-critical systems such as healthcare. And this is one of the examples, a recent example, where generative AI is being trialed to help doctors write notes, clinical notes. And this is a very time-consuming process. My sister is a doctor, and she tells me that's the 50% of her time is about writing those notes. And as we know, our healthcare system is really facing shortage of doctors, so these systems can really help. But they open up quite a few questions around the ethics, the values, the reliability, the safety, and other issues that you probably have already heard in this conference. So yesterday, in this session, there were a few references to testing, and in particular, Mark Hammond was talking about how we can use testing as one of the many tools to safeguard these systems. Both, he was referring to the software engineering tasks, that is, if we if you use generative AI to repair our code, then testing can help us assess the repair and say, oh, yes, this is truly indeed a correct repair, because often these systems can hallucinate and can give us the wrong answer. And so it can be quite time-consuming for people, for developers, to assess those solutions and choose the right from wrong. But testing can also be used for generative AI-based systems beyond our software engineering domain, to test, for example, these AI-based systems used in healthcare. But these systems are quite different, and as you heard from the keynote today, quite different from the traditional software engineering systems. And they present new challenges. You've heard about many challenges that they present. And as I was thinking about this talk, and this was prepared in 5 hours, as Has said, yesterday I was told, well, would you like to present? And this list of challenges was quite a big list of challenges, a long, very long list. And I had to distill it, and I had to shorten it, because it's only 10 minutes, and I cannot talk about all the possible challenges that are here. And so for me, the most two important challenges in this space, in the sense of testing generative AI-based systems, are two. And the first one, the first one is not a new challenge for testing, but I think it's even more, it will be a bigger challenge, is the Oracle problem. When I talk about the Oracle problem, what I mean is usually the Oracle is the human that determines whether the software system exhibits a correct behavior or not. And it's been a long-standing challenge in software testing because it is a time-consuming task, and it takes a long time to label these test cases for correctness. But now, when it comes to generative AI systems, it's not anymore, well, correctness is one thing, but there's many other things that we need to care about. And we talked about, in previous talks as well, human values, ethics, fairness, and other aspects in terms of transparency, and other properties of these systems that are new for us. And in particular, when it comes to these human aspects, such as values, how can we build an oracle that can tell us whether a test case, whether a solution generated by generative AI is indeed fair, or is indeed unbiased, or adheres to our human values? And it was quite interesting today as well at the keynote, where Liming was talking about that humans, we need to have these bots that are checking whether the generative AI is doing the right thing. So these bots are the oracle. And how can these bots then know how can they learn about our human values, such as fairness, for example, or security, or other kind of values? We're doing some work in this space, but what I see in software testing, most of the work is focused around the fairness and how to test, but not around how to build these oracles that then can help the automation of software testing in this space. And the second challenge, and again, there's work in the community around this, is how do we know that we've tested enough? And how do we know that after testing, these systems are ready to be deployed and won't lead to any disasters or any life loss, or, for example, the doctor writing the wrong note for the patient? And the space that we've been working on in testing, we call it adequacy metrics. You know, how good the test suite is, how well have I tested the system, what kind of new test cases do I need to generate, what are the strengths and weaknesses of the system. And mainly we've been focusing on coverage and diversity, but these metrics are not sufficient anymore, so we need to be thinking about new adequacy metrics that can guide us in terms of telling us, well, the system is good enough, is good, it's not just good, it's safe, it's reliable, it's unbiased, it's transparent, and all those other properties that we've been talking about in this conference. So these are the two challenges that I think in my mind, and I know probably if I had a bit more time, maybe my answer would have been different, but this is where I'm at. But I'd like to just briefly talk a bit about, so I'm talking about testing, and there's work going on in the community around using generative AI for testing. And this is quite a new and emerging area, and it's quite an interesting area. There's great potential there. We're not there yet. The state-of-the-art generative AI systems produce only 40% correct test cases compared to 100% when we are using search-based software testing, and up to 47% coverage, while we are achieving 100% with search-based software testing. Well, they are useful tools to use generative AI because the argument is that they produce human-readable tests, whereas with search-based software testing, readability may not always be there. So it's an interesting area to explore, and lots of potential there as well. I would like to finish with my prediction for the future. And as the very wise Niels Bohr said, it is difficult to make predictions, especially about the future. And I like this quote because it also relates to the importance of testing. And these generative AI systems have been trained on past data, and they're not very good, to predict things about the future. And this is another argument on why we need testing, because with testing we can generate these unseen cases and improve and safeguard these systems even more. So thank you for your attention.
Thank you, Aldeida, for a very nice talk, and many thanks again for stepping in the last minute. So now it's my pleasure to invite Professor Laurie Williams to talk about the future of software security.
All right. Well, it's wonderful to be here today. I'm Laurie Williams from NC State University, talking about software security. And so I'll start out with just a little bit about, what's going on now. Not the future of software security, but what's going on now. And so one of the things that dealing with is people who are just attackers for money. And this is an example on the left. It's a couple years old, but there were attackers who got into the Colonial Pipeline and stopped automobile gas flow on the East Coast for a couple of days. And so I was part of that. But the main thing is, if you look at what Brad Smith says, the president of Microsoft, is that there's a growing privatization, there's a growing industry, a $12 billion industry of people who are attacking for the money. And the Colonial Pipeline hackers say, we actually didn't mean to make all that chaos, we just wanted the money. So that's one thing. And then also Verizon data breach report is a report that they study worldwide annually. And last year what they said was they've never before seen the attackers coming out swinging the way they are now. And these are financially motivated criminals as well as nation-state actors. So the state of what's going on with security is like every trend that you see is getting worse. And so although this is the future of software security, I'll also say now is the time. This is the time now that we can't wait to the future. We have to look at it now. And this conference is made up of research, education, and practice. And so, as researchers, one thing we need to do is to understand and address practical security problems. Educators need to educate students, so in the beginning, they learn to code securely. So they don't have to learn to code and then, oh yeah, then to do it securely, you do these things. And then practice, there's practitioners here, is to use a secure software development lifecycle. And as an aside, in the US, because of supply chain attacks, which I'll talk about in a moment, now if you want to sell to the US government, there's this self-attestation requirement, which means you have to, quote unquote, use good software security practices. So as a software security person, that's good news that people are being forced to do it. So it's really a hair on fire kind of situation, meaning, it's chaos. But one thing that I'm in my sabbatical right now, and one thing that I do here is when I ask people in industry, how do you learn about what's going on, what the latest thing is going on, practitioners actually say, we read academic papers. So what a tremendous opportunity we have now to have a practical impact. And so animation came off a little bit, but happy that there's 8 tracks on software security at ICSE. That's wonderful that we are addressing software security in this conference. As we do, our researchers, we can either work on the state of the art or the state of the practice. Where the state of the art, our stakeholders or other researchers, we're more in theory, and we're, our audience is people who will build upon our work, researchers that will build upon our work. State of the practice says we really want to have a more near-term direct impact. And so, what I'll just say about that is that there's real problems out there now. And the more researchers can work, listen to what's going on and attack real problems and have impact right now would be great. And the impact is on practitioners, security analysts, educators, tool vendors. How can we help them out? That person with their head in their hand is a practitioner who's overwhelmed because now they have to produce functionality really quickly and have it be secure, and it really disrupts their workflow. And that's something, again, as researchers we need to be thinking about is, how do we automate this? How do we minimize the impact on the workflow as we make more secure software? So the attacker is a persona we just can't leave to the security people. So whatever research, whatever education, whatever you're doing, as much of a positive person as I try to be, you have to turn it around and think about how could this be used for bad? How could people, the attackers take advantage of this across the entire software development lifecycle? And so in security, we often talk about prevention, detection, and response. So how do you prevent a vulnerability in the first place? How do you detect one that's already there? And how do you respond? And as software engineers, we need to be thinking about all 3 of those. And so from a prevention standpoint, it's the requirements phase, architecture and design phase, implementation phase, and then build and deploy as code. So you hear things like infrastructure as code. That code is as much code as anything else's code. It can have security vulnerabilities, and it really impacts the environment. And so from our standpoint, we do need to be thinking about all of those. I didn't really do an in-depth analysis of the 8 sessions, but I think that the prevention is probably the least approach by us. And we need to be thinking about how do we get it into that stage. And then the next is detecting. I think we've done quite a bit. I think most of the papers, security papers in this conference are in vulnerability discovery. And to some degree, so build and test as code. So what are the vulnerabilities in infrastructure as code, in GitHub scripts and whatnot. Not as much, but a lot on vulnerability discovery. So that's great that we are addressing that. And then response. So how do we fix vulnerabilities quickly? How do we debug them? How do we deploy them to customers very rapidly? Because it's kind of an emergency situation is something that we can look at. And so I'm going to give a brief case study on software supply chain security, which is what I spend essentially all of my time now. Sonatype is an organization that does some data analysis, and they recently said that there's a 747% average increase over the last 3 years on software supply chain attacks. So software supply chain attack are all of the open source, all of the the components in an ecosystem the build infrastructure, the people who develop the software are all part of the software supply chain. And I would love any collaborators. So if you're interested in the topics I'm going to go through briefly, would love to collaborate with you. We have a large $9 million grant in the US, and we would love international collaborators. So what I'll talk about now are the 4 major attack vectors of software supply chain. One of the attack vectors, so attack vectors, what are attackers use to get in? So one of them is accidental vulnerability injected. So that's happened forever. A developer accidentally puts a vulnerability into a component that's in the ecosystem. People download that component. The component or the vulnerability is discovered, and attackers exploit it. Log4j, if you follow software supply chain, was an example of that. That poor developer who put that in there and caused havoc throughout the world, but that's what's been going on for a long time. The growth is really in especially the next 2 attack vectors and a little bit maybe on the 4th. So a new attack vector in supply chain is using codependencies as an attack vector or using codependencies as a weapon. So that means attackers explicitly putting malicious code into open source so that people download it and then they can exploit it. And that's something that's happening more and more that really wasn't happening more than a few years ago. An example of that is Node IPC, which is a popular component. Back at the beginning of the Russia-Ukraine conflict, there was someone who put into Node IPC a test. If your IP address is in Russia, we're going to delete your files. And that went on for a bit until GitHub took it down. But I mean, that's an example of what attackers can do. And then another new attack vector is to use the build infrastructure as an attack vector. So you may have heard of SolarWinds and CodeCov as 2 prominent attacks. And what those do is really using the compile, deploy, build pipeline as an attack vector. And that's something that hasn't happened much before, and it's really an area that needs a lot of research because industry is really trying to grapple with that. And the newest attack vector in supply chain are those, generative AI, LL, the large language models as an attack vector. And in this attack vector, there's a lot of code being generated, as we just heard. And if the training data has vulnerabilities in it, then the generated code will have vulnerabilities in it. And that's more of the accidental injection, but also more increasingly, they're finding ways to put vulnerable code into the training data so that more vulnerable code is generated. Something that we really need to get a handle on. And then the last thing is just humans. So everything I talked about before is technical, but humans are important to be thinking about, whether humans be attackers or software developers that are now overwhelmed by everything that's going on. And so trusting trust. So it's the humans in the supply chain that we need to deal with. And there was way back in 1984, Ken Thompson had a Trusting Trust Turing Award, and he said, to what extent should one trust a statement of a program is free of Trojan horses? Perhaps it's more important to trust the people who wrote the software. So important to be thinking about that. And to finalize, so now is the time to work on security, but we can also think about software security in the future as well. From a research standpoint, we need to make sure we're listening and understanding for the practical problems and getting more research in the areas of prevention and responding, because there's not as much research there. And then the science of security. How could we actually develop a science of security to get underneath what the attacker's doing rather than reactionary? Education, as I mentioned before, teach students to develop securely. And then in practice, always remembering the attacker persona, and then fitting these software security practices into your workflow so that they're as natural as brushing your teeth. You'd never want to not brush your teeth. You'd never want to develop insecure code. All right.
Thank you, Laurie, for sharing your thoughts on the future of security. So it's now my pleasure to invite Professor Gail Murphy to talk about enable flow in software development.
Okay, thanks everybody. It's a little bit intimidating to give a talk after the last 2 speakers, so here we go. What I wanted to talk about is a little bit more about the context of how at least some software gets developed. In a particular enterprise software where there's a need to deliver software with certain kinds of capabilities to people who actually want to pay for it. And I think that opens up some questions that maybe we don't ask often enough in this community. So if we think about software engineering research today, where there's a lot of focus in conferences like this on the technical artifacts, because after all, we're about engineering that software, those technical artifacts that we produce. And there's research that takes a look at how do the people actually create those artifacts. Laurie was just referring to the fact that, humans are part of that part of creating the software and part of what we have to think about with software security. And we think a lot about how these two things interact. So how do the people interact with creating the software? How does the software impact how the people are actually creating the software and sort of the circle that goes on there? And as well, we start to think about ways that we can describe what the software that we're building should actually do. What are the requirements that we need? And we have other kinds of research that's going on in testing, as we've already heard this morning, and how do we ensure the reliability of the software, and lots of other topics. We have a lot of talks that are going on in this particular conference. But are we focusing enough actually on the flow of being able to take the capabilities that users who are going to buy the software want to have and making sure that it really gets through the development process in a way that delivers that software value to the businesses that are trying to produce it? And this is a lot of the commerce that goes on in the world of software development, right? Is how do you get those requirements that the users want actually out into their hands and use so that they'll actually pay you for them? And this talk is kind of informed by the fact that I helped run a software development organization like that for about 15 years. So if we take this and flip it and don't think about software engineering research, but instead take the viewpoint of what's happening in the company that's trying to build that software, let's take a look at what that actually feels like from that software development organization's point of view. For that organization, there's a system that they want to produce. There's a system that they're going to sell to the users who are willing to pay for it. And that system has to have a bunch of things in it, features, that users actually want to buy, they want to use. Sometimes there's just things there to be competitive with other products in the marketplace, but there's a bunch of functionality that you have to deliver. And you have the user. The user is constantly generating an evolving set of new desires and needs that they need in that eventual system. We might call that an end user, as was indicated in the keynote yesterday, but we have that continual change pressure that is on our systems, and that's a well-known law, from the early days of software engineering research. So our goal as a software development organization is how do we actually get that needs that the user has encoded into the system and deployed and delivered to them in as reasonable amount of time as possible. Now, for some companies, that's seconds or minutes. For other companies, it might be a bit slower. It depends on the other qualities that you need to meet in the software you deliver, like perhaps taking more look at security. So often the way that we think about this problem within our community, I think, is still focusing in on the middle of that. Focusing in on the fact that we've got technical artifacts, we've got people that need to deliver those technical artifacts, and really focusing in on that piece of the problem. And there's been more recent work, especially in industry, about saying how do we take the changes that we're putting in the technical artifacts, the code, and flowing them through DevOps practices into the system. And I'm not going to talk about that too much because we have such well-developed techniques to be able to do that. Where I think things get a little bit more fuzzy and where there's a lot of opportunity for the future of research in our community is to start thinking about how do we actually figure out what the users want in the first place. Well-developed methods within our requirements engineering communities to think about that, but it's still not quite crisp. And if you look at organizations using agile development methods, it's not actually easy to go into them and say, so what are your requirements? Because they're going to point you to 7,000 issues where there's a bunch of requirements that are spread around in different kinds of opportunities and descriptions. But it gets a little bit more complicated than that when you're in a software development organization. Because you do have your product engineering team that's responsible for a lot of the requirements. But for these enterprise kind of software development organizations, you've also got a sales team. And the sales team are the people actually talking to your potential users. So they're the people that are out there also gathering a form of requirements, sometimes perhaps selling things that may not actually be implementable, which is why they should be talking to the development team. But you start to get all these interactions between all these people. You have the salespeople thinking of requirements in a particular way. They're feeding them to the product engineering team. There's the end user there, the eventual customer of the software, and there's a lot of interaction that goes on. And if you know that game of telephone tag, there's a lot of misinformation and miscommunication about what actually needs to be built. And of course, even though I depicted it as being fairly straightforward to have this development team, it's pretty complicated. We just heard about supply chains. You know, your development team isn't going to be one little tight group of individuals. You're going to have multiple teams. Each of those teams is probably working on different parts of the value chain that you're trying to produce, and they have a lot of communication that is going on amongst them. And they're not only trying to think about what is the flow of the eventual requirements that are going through to the system, they're thinking about the defects they have to fix. They're thinking about the technical debt that they need to start working on so they can make that flow continue to go in terms of the value. Because that flow of value is the thing that's bringing in cash into your business and allowing you to keep going. So this would be bad enough, but in fact, there's more people that are involved in a development organization like this. For enterprise software teams, you often have a customer success team. These are the people responsible for actually taking the software that you sold and actually getting it installed, whether it's cloud or on-prem, deployed and used by the customer. Because that's when you actually start to be able to count the revenue that you're trying to bring into the organization. And that customer success team, often part of the sales team, is kind of feeding back into that whole cycle on the right-hand side of the requirements and the sales team. So I think sometimes when we talk about software development in our community, we tend to think of it as kind of this very straightforward, siloed kind of opportunity that is connected together in some way, but we don't always admit that there's a lot of messiness in how software is actually produced that is important for the commerce that goes on. So what are the research opportunities given this? Well, I think there's a lot if we start to think about the techniques that we're building in terms of this messy world. We've got businesses that have this continual requirement on them to produce value to their customers. Like I said, that's been around for a long time and it's not going away. We've got our community that is building all these really interesting techniques, often focused on a particularly specific part of producing this value chain of software. And so for us, I think that's a ton of opportunities. How do we take some of those techniques we think about and think about them in this much, much messier world that we have to deal with? So here's some questions that I think come to mind when you start to think about what we do in the context of how organizations actually build software. You know, it's hard enough to figure out how we should specify requirements, but how do we track them? How do we know when they're actually delivered? How do we know when they're actually used? It sounds like that should be easy, but it's not actually that easy to do in a lot of the practice that I've been exposed to. How do we ensure that these people that are involved, developers, customer success, sales, how do we ensure that they actually communicate efficiently and effectively? Do we need to organize our teams in a particular way to be able to enable this fluid delivery of value? There's questions about technical debt. There's questions about when is the flow actually being interrupted? Where are the friction points in going from requirements to delivery of that functionality? And how do we overall, we make it much more easy to evolve our systems really gracefully? So in the end, what we want to be able to do is take the needs of that user. We're the software development organization. We want to produce that system as fast as we can in a way that's as reliable, as secure, as responsive as we can be. And if we start to think about the detailed questions that we often consider in our community in the context of this business reality, I think a lot of really interesting questions, as I said, came up. And that really requires thinking about a lot more about how the individual techniques that we build, how do they impact not just how the humans interact with the technical artifacts that we deliver, but how do we deal with those human-to-human interactions? Because if we can't get that right, It doesn't matter how much code we auto-generate. It doesn't matter how much we're auto-testing the system. We're still going to be limited by a lot of those human-to-human interactions. So I think that's good news for our community because AI advances are great, large language model advances are great, but at the end, it's still humans that are going to be deeply involved in delivering software. So that's it, and I look forward to the discussion later. Thank you.
Thank you, Gail. So it's my pleasure to invite our last speaker, Professor Lionel Bryan, to talk about the future, how AI impact the future of AI.
Can you help me? Hello, good morning. So when I was a PhD student a while ago, machine learning was a maverick field. You would actually get scolded when applying it in your research by everybody. And I started basically using machine learning for the purpose of various software engineering tasks when I was doing my PhD at the NASA Goddard Flight Center. And now, actually, in this community, you hear people complaining about the overwhelming presence of AI at ICSE, and mostly in private. And as you will see, there are good reasons for that overwhelming presence. And I did not step, I did not step in for that talk at the last moment, as opposed to the first speaker, but I nevertheless prepared my talk between 2 and 3:30 a.m. So it might be a bit more creative than intended. We had a great keynote this morning on the same topic, but I hope that what I will be saying is complementary to what he said. AI in software engineering, you have the usual dichotomy, AI for software engineering and software engineering for AI. So let me start with AI for software engineering and then go into an example. I see a number of applications that are emerging. You can see actually a number of papers in this conference on this topic. One, for example, is optimization, where meta-heuristic is used. Meta-heuristic search is used. For example, to maximize test coverage. Prediction, obviously, using regular machine learning, deep learning, large language models, for example, for test selection in the context of test prioritization. Information extraction, for example, for extracting requirements from legal and regulatory texts. And I have actually a colleague talking about that at 12:30. Transformation, for example, for repairing test code when there are changes in the production code. Generation, obviously, the first speaker spoke about that. Generating test input with GANs, for example. Generating images, for example. And usually, automation solutions, in many cases, tend to combine several of those applications where you need to combine information extraction, prediction, optimization. It's actually pretty common. And actually, there aren't that many alternatives to AI for many of those things, or not many alternatives that work as well in many cases. So, for example, this is a project I was involved in with a satellite company developing real-time systems, and they wanted to not only make sure that their critical tasks would meet their deadlines, but they wanted to know what were safe worst-case execution times for their critical tasks. And here the solution was a combination of evolutionary computing in order to find worst-case task arrival times, combined with machine learning in order to identify, I don't have a pointer, but no, yes. In order to identify the boundary in terms of worst-case execution times of the various tasks between safe and unsafe execution. That is, between execution that had a high probability of missing deadline and executions that had a very low probability of missing deadlines. So it's an example where evolutionary computing, as an example of meta-heuristic search, and machine learning are used together to solve a problem. Now, concerning software engineering for AI, and we have heard a lot about that in the keynote this morning. As you know, one of the issues we deal with, which are uncomfortable for software engineers, is that very often for those AI components, we don't have specifications, and of course, we don't have source code. And the behavior is learned from data. So then we have to worry about data quality, bias in the data, the representativity of the data. We have to worry about using appropriate model architectures and tuning, which is a very important part of the process. There was a great paper earlier on yesterday about federated learning and debugging in federated learning. And for example, we can get a lot of inspiration from what was done for software redundancy in the context of fault tolerance, where you had many components and somehow based on the output of those many redundant components, you had to make safe decisions. And in the context of federated learning, you have many models that have been built in different contexts, and somehow you need to combine the output of those different models. So there are similarities. So there are many things we have done in software engineering that can be adapted to address problems in AI systems. So we have, of course, an important role to play. And of course, last but not least, regarding trustworthy AI, that is how to ensure that, for example, AI systems are safe or fair, we can benefit a lot from our experience in software V&V. And you have a lot of papers on that in this conference. So as you can see, there are a lot of reasons why we are, AI is taking by storm the software engineering community, and why there are so many papers nowadays using or adapting AI for various software engineering purposes. As an example of what I just said, when you are testing deep neural networks, very often you have a very large number of inputs that are not labeled. The cost of labeling is very high in most contexts. The cost also of execution of very large models is very high. You cannot just run hundreds of thousands of inputs. The notion of coverage doesn't make much sense in that context, as shown by many empirical studies. Very often the internal of the models or the training set is not even available. You don't have access to it because the model was developed by a third party, and that's not available. So you somehow need to select a test input based on, you need to select inputs based on, sorry, there is a typo, on input diversity, for example. And in order to do that, you can reuse and adapt a lot of the work that has been done in the community known as search-based testing, or the community that uses meta-heuristic search techniques for testing to address that problem. So that's an example where our experience in standard software engineering can be adapted to new problems in AI systems. And of course, I could come up with many, many other examples. So what are the lessons learned? Is that in my experience, for many software engineering problems, automated, practical, and scalable solutions usually involve some form of AI. It doesn't mean deep learning. It doesn't mean the large language models. It may be meta-heuristic search. It may be other forms of AI. But usually it's a combination of techniques because they are quite complementary. Usually when you automate something, you need to extract information, you need to predict, you need to optimize. I mean, all those things, all those components are usually necessary. But also, it has to be effectively combined with other more standard techniques like program analysis, solvers. And usually the complexity and the intelligence of the solution is on how to intelligently combine those different things together. It's not in using one thing. And AI technology is moving fast. I mean, we have heard about large language models, but I could also take the example of more recent techniques for few-shot learning, which enable learning on small number of instances. And of course, we seem bound to react to new opportunities, and it's hard to avoid, you know, because those new techniques come up, they work better, they allow you to do things you couldn't do before. You kind of have no choice but to investigate what you can do, you know. So it's a bit unpleasant to be running after the quick progress of AI, but we don't really have a choice. However, we should not just randomly try AI techniques because it's fashionable. There should be good reasons to experiment with a new, more complex technique and clear benefits over simpler ones in terms, for example, of accuracy, learning and prediction time, data requirements, because some techniques are very data hungry, others are not, or less. So, for example, recently, I was doing analysis of logs to detect anomalies with colleagues. And there were a lot of papers using LSTMs, transformers, and you find all those papers to detect anomalies in logs. And you know, we tried random forest with a few features that we defined, and it was as accurate, and it required less data. Prediction time was quicker, learning time was much quicker. So you know, then you wonder why all those papers, you know, without even trying something simpler first and more practical. And also, we should not blindly use AI techniques. We should always have a well-defined software engineering problem that takes into account the practical engineering context that we target. We target, you know, I don't know, real-time embedded systems in a certain domain with certain constraints, with certain standards to comply with. And we can't just work on very generic problems because then we don't know what are the working assumptions, what are the practical constraints we have to work with, and that's important. We are not AI researchers, we are software engineering researchers who try to apply AI intelligently in combination with other techniques. So maybe, how much time do I have? Oh my God, okay. So you have heard about language models, but I guess I will skip that. I've been a bit longer than expected, even though people might have, again, find that this is a little bit overwhelming and that everybody's writing LLM papers. There are also good reasons why, for example, in VNV, they are useful, but I guess I will skip that. Sorry for that. So to conclude, in the future, what are our challenges in using AI? If we talk about evolutionary computing or meta-heuristic search in general, which is again an important class of AI techniques, it's not just machine learning. For example, for optimization purposes, very often we are dealing with very large search spaces and we have a scalability issue. So we need to find ways of improving scalability. And there are techniques, there are more complex new algorithms, for example, co-evolution algorithms, or strategies to partition the search space. We need to be able to exploit better large amounts of unstructured data, whether it's text to extract requirements, as I've mentioned, traces for anomaly or failure prediction. That's still in many ways a challenge. And we need to combine AI with formal reasoning. We need, again, to find intelligent ways of benefiting from the strengths of all the techniques available to us, and not just be obsessed with AI, but understand how AI, in general terms, can be, for example, intelligently combined with symbolic execution, constraint solving, and so on. And also effective transfer learning. There was another great paper yesterday talking about that. Transfer learning without fine-tuning. I still need to read it, but the talk was interesting. And in order to adapt to new tasks quickly, because we work in an environment where software development changes, system changes, technologies change, and we need to be able to adapt quickly. Thank you.
maybe I can start asking the question first. So this is the future of software engineering. So I want to ask each of you, what would be the futures of ICSE like 20 years from now, like 2043? So what problem we solving then? Are we going to have papers that are co-authored by human and AI? Right. So in ICSE 2043, what is it going to be look like? Okay, maybe I start from Aldeida.
Do you remember our last statement on our last slide?
It's hard to predict. Okay, okay, it's a hard question. 2043, you said? Okay. 44. So how will our community look like? How will our papers look like? And how will our research look like? I haven't truly thought about it. But it's interesting how we're dealing with ChatGPT as an author at the moment. There are cases where actually ChatGPT already has appeared as an author in certain conferences and also in journals. So there are cases where that's already happening. But I don't think we will have ChatGPT in the future. I think current large language models will become obsolete very quickly because they don't really understand. And some people call them statistical parrots. So they are regurgitating things. And yes, they look quite impressive, like DALL-E, generating all those amazing images and amazing text. They are truly impressive. But they don't understand what they're saying. They don't understand how they're doing it. So if we want AI, truly, AI that is a partner in that sense, like an author in a paper, or have we been talking today in terms of a partner in research and a partner, like in the keynote, a partner in creating art, I think it will be a different kind of AI, and I think that will open new problems for us. So I think ICSE in 2024 will look quite different, I'd say.
It's 2044, right? Oh, 2044. Yeah, and it is a hard question, too. I agree, maybe it's not going to be the same as it is now, but I think it'll be even a more formidable situation. I know, like, it was only about 2 weeks ago when someone told me it took 3 years for these databases, the training data to be generated, and I was relieved that things wouldn't just be real time all the time. But I think they probably will be real time. I think the training data will probably be real time at that point. And I think the further we go, the more generated code will be everything. And it's kind of like us with assembly versus our languages now. Then our languages now will be the assembly, and generated code will be what's happening and be trusted by lots of average developers that that don't know. And so I think that we have a lot of challenges ahead of us in every domain, every part of software engineering, be it security or other, based upon how it's going to evolve. So.
I mean, if you had asked someone in 2003 to predict where we would be in 2023, I don't think anybody would have had any idea. I mean, in 2003, deep learning research was not even being funded. So, they were a very small minority in the AI community, So I don't think that's possible to predict anything. But on the other hand, I don't believe that humans are going to, as some people say, that software developers are going to be completely replaced. I think AI is going to assist people. It's going to be a tool in making people more productive, in helping people deal with large amounts of information, in automating some of their less creative tasks. I don't believe humans are going to come out of the loop or out of the development process for software systems.
It's always good to be the one who can go last. I guess sometimes I think about what would it have been like back in, 1968 to 1970, and the first software engineering conferences when, compilers came along, and oh my goodness, people wouldn't know all the code anymore. So we always have new approaches that are coming. I think Dave Parnas one time wrote about the fact that it didn't matter what we automated, there would be another level that we would strive for. that would always be beyond the boundaries of the abstractions that we could deal with at any given point. So my sense is we'll be in a different place, we'll be building different systems in a different kind of way, but a lot of the fundamental problems that we face in software engineering are still going to be there. Still going to be about what does the system need to do, how do we make sure that it's doing it well, how do we make sure development is doing it effectively. What I hope we can get to is what we've talked about since I've been in this community, which is having a better spectrum, and I think we're making progress there, of having industrial developers that are dealing with the problems every day, together with the research community that is thinking about the problems that are coming or thinking about the problems in a different way, and really seeing that breadth of new techniques through to actually applying the techniques and having really robust discussions about what the next future will be and having the research community involved in those discussions. So that's a pretty generic answer, but that's where I hope we'll be.
Thank you. So now, that's a question.
So one question that is something I've thought about from a software societal perspective is, what are the legal liability challenges when software that has AI is used for making critical decisions? For example, for things like deciding who gets loans, or deciding, for example, or even things like self-driving cars, if they kill somebody, how is legal liability assigned? And especially in the context of security, when in the critical, the pipeline example that you gave, or where software really resulted in people's lives being inconvenienced and perhaps even endangered. How should we as software engineers think about the legal aspects or the ethical aspects of the ethical consequences of the software we build? So I'll leave it there.
Yeah, I mean, I'll say in the U.S. and then other people are from Europe, and you may be able to answer more, but liability is a thing that's coming out now. In the U.S., there was a cyber strategy, and liability is now being spoken about. And when I was at a dog show a couple of weeks ago, someone mentioned that in Europe it's the same. And so, I think it'll be a new world for us, where liability is a thing. How you actually attribute to, I would say with AI, it may be hard to attribute where the source of the problem was to hold someone liable, but maybe I'll call it regular coding, maybe it's going to be actually you're able to attribute it to someone, and liability will be a thing.
I don't know if you have seen it, but there was a recent article by Joshua Bengio where he took the position that at this stage we should not have fully autonomous systems relying on AI. There should always be a human in the loop. And of course, it's true that given our ability at the present time to address trustworthiness issues in AI, it may be a responsible thing to do, not to enable AI to fully automate, automate a task without any human supervision. Maybe.
But do you think it's possible to put that genie back in the bottle? We already have autonomous systems that are using AI, right? Like Tesla cars and the like. So I don't know. But anyway.
Yeah, but we have to reflect on whether or not that's a responsible thing to do when the decisions made are critical, of course, not when it's about which advertisement you should get on a web page. I mean, who cares? But for a bank loan, for of course cyber physical systems. Involving human life or the environment. Yeah.
Liability might be the great damper on AI, right? And in its use in systems, because if you're a company that's trying to produce and sell software and you suddenly have to attest that you've followed certain practices or the software is going to have certain capabilities that you can ensure have the guaranteed properties that you've said it will, that's a real damper on what companies are going to be putting in their software. It's hard enough now to do the bill of materials for open source in your software supply chain. So we have a lot of excitement about this, but the reality of an engineering discipline is probably going to come crashing down on at least some sectors to some extent to be the great damper.
Maybe just quickly, I don't have much to add, but related to liability in Europe as well, is the AI Ethics Act, or I can't remember the right name for it, but what it says is that if you put a source of code, I mean a language model in GitHub and somebody uses it, you're liable, if something goes wrong. So I think that's, it's happening both in the US, Europe, Australia is a bit behind. I think, but more and more the government is investing in the area of AI and in research in terms of coming up with these legal kind of safeguards.
Thank you. Any more question? Yep.
So it's a pretty broad question, so I'm not sure how to frame it. But from the discussions and the keynotes that I've seen, for example, yesterday, there seemed to be like an increasing link between software and law, in the sense that, for instance, like you were talking about like software testing. How do you test your AI so that it follows a social contract? And that's kind of like a difficult point, right? That it has to be fair. And that wasn't like something that was, I think, as much of a problem before. It was more like a lawyer's problem. But now it becomes kind of the developer's problem. And like this liability, as you said, is kind of digging more deeper into the code. So it's not really necessarily that like you have the legal team and you have maybe the software team. And they like you just ask the lawyers when you have a legal problem, and then you ask the like computer guy when you have a computer problem. But it seems to be like there's an increasing kind of like link between the two. Any reactions to that? I don't know.
Yeah.
Yes, you are right. It is not just the law, it's also, for example, a regulatory framework. For example, safety critical systems have to comply with functional safety standards. And in many, many domains, energy, automotive, aerospace, and so on. And how do you demonstrate compliance when you rely on AI? Because all the techniques that are recommended, or not all, but many of the techniques that are recommended in those functional safety standards are not really applicable. So there are new standards that are being defined, but they are very vague. They don't provide much guidance. For example, there is a well-known so-called SOTIF standard in the automotive domain, but it just tells you what you should achieve. It doesn't give you any guidance on how to achieve it. So it's not just the law. And then, of course, you have the legal aspects, which is even worse, I would say, because it's even more open to interpretation. That means you have to have clear regulatory and legal requirements that you need to verify on your AI-based systems to start with. Okay.
No, I mean, so for a long time now, I know there was a professor at NC State a while ago who was at the intersection of law and software engineering. And I mean, and that was more than 10 years ago. And if you think about not just AI, but just you have a privacy policy. Does your software actually comply with your privacy policy? That's a difficult thing. In the US, does your software comply with HIPAA? These are very difficult things that really does bridge the intersection between law and software engineering. So I think that actually that's a great field if someone's still in their PhD or whatnot, to be thinking about that intersection, because the tie is only getting stronger and stronger as regulations and standards and compliance is a bigger deal. So it's just going to be more where we need to understand both at the same time.
Yeah, I guess I'll answer it from more of a business perspective. So we started our company in 2007, and we spent a lot of time with lawyers. Over time, our development team had to become more involved with understanding the legal compliance that we were signing up to. So whether it was HIPAA, or whether it was export control rules in the US that you were then attesting to, that you hadn't used some piece of open source created by somebody in a country that the bank that's buying the software isn't, and it goes on and on. So I totally agree with Laurie that this is an incredible field to get into, because in general, if I go back the last 10 years or so, the people that you're dealing with on the legal side, they don't understand components and supply chains and technical dependencies, and you get into arguments about library dependencies versus other dependencies. It's frustrating on both sides, so we need people to bridge that gap.
Not much to add, but you mentioned, just wanted to briefly say that, these new quality attributes, if I may call them, privacy and, privacy is not very new, it's been before, but it's perhaps opens new challenges in this age. But there are these other things that you mentioned, like fairness, for example, and other properties that we didn't need to care about in the past. These are related to human values. And then the question of who decides what's fair and what's not fair. I think that's a difficult one. And there was the talk by Sarah Pink yesterday, which was a wonderful talk, where she was talking about co-designing with humans and involving humans in the development of these techniques. And I think we should be doing more of that, considering the human aspects of software engineering.
Hi, sorry. I've got way too much to say on this topic, so I did think of something, like most of what I'd say would be statements. So I did come up with a question that is not actually pertinent to exactly what I do. But if we think that a human generation is kind of 20 years, and there's estimates that the number of developers in the world is doubling every 5 years, so the next 20 years is 4 generations of developers. What do we teach the next generation?
Want to go first? Okay.
Nice move. I think a lot of the, I don't have the total answer to that. That's a big question, right? But I think one of the things we have to think about is how do we teach our students actual critical thinking, and how do we get them to interrogate results in code that something might give them, as one example. And that's a really, really hard skill to teach. And one thing that I always think about as I'm trying to figure out how would we do that is how much are you going to still have to understand the code? And so there's a real challenge, is that at least in experiments we've done with developers at times, they really want to move through code very systematically, understand every line, because that's how they build up their mental model and think about the code that they're working with. So now if you're a second generation developer from now and you've got a slew of code that you were just given, how do you figure out the right interrogation or tests or whatever to decide what that code actually does, and if you can make the attestation you are now asked to make? And that is going to keep people busy for a long time, I think, figuring out how to teach people that.
Yes, what I'm wondering is that I think, for example, for a typical bachelor degree, at this point, there is a bachelor degree in computer science. There is too much to teach, I think, within a program. And so maybe we have to start thinking about specializing the degrees with, of course, common courses, but eventually have maybe, I don't know, software engineers who specialize on embedded software, others who specialize on, information systems, or I'm not too sure how even to specialize those degrees, and maybe others that are more at the intersection of software engineering and AI. But we have to start specializing, I think. Otherwise, I don't see how we can fit everything that is required in a 4-year program.
I guess a couple things come to mind. One is what I talked about earlier, is just teach people to write secure code, whatever that means, whether it's in security requirements, design, architecture. So that's just how they know. So that's one thing. I agree with Gail's critical thinking, and if these, I'll call them higher level languages, that come out of large language models, how do you not trusted by default, and how maybe it takes multiple people together with diversity of opinion to look at, like, what is this really doing? Because if we just assume they're right, that's where I think we're going to get in trouble. So, I think that's critical thinking combined with maybe diversity of opinion, ways to work together like that. And then, again, what Gail said in her talk, it's the human-to-human interaction. And I think our students need more and more of that. How do you work together? How do you communicate? We need to continue on that domain.
Okay, again, I agree with everything you said. But to me, Gail, critical thinking is also the top. And it was interesting to see even in the presentation, some people, for example, would say, I asked GPT, this is what it said, and I have nothing to add. And I feel like these automated techniques will have this impact on us that we will maybe not stop thinking, but stop questioning and agree, and maybe, I don't know, we might become lazy in thinking. So I think critical thinking is the top, and human aspects, human collaboration, I think, very important.
I just want to add something in addition to critical thinking. I think that one of the main purposes of education, in particular undergraduate education, is for people to learn how to learn. And that's, in fact, the main thing you do in an undergraduate degree. Because most of what you learn, you'll forget. And it tends to become obsolete over time in our field. So learning how to learn. But how do you teach that? That's another story.
There's a question in
Hello, I have a question that do the SE community need to rethink about productivity in the AI era? And how would the advance in AI impact the research directions in software engineering? These are two of my questions.
So you start first this time.
So how it will impact productivity, AI, and how research will change, right? Because of
exactly.
AI. Great question. Thanks for that. Well, hard to predict again, but it's already happening. It's already changing, and in particular, I think it will have a big impact in software engineering, both in terms of research and in terms of how we develop code. As I mentioned in my talk, already in the industry, AI is being used in all different stages of software development. So it will become more and more, increasingly being used in terms of developing software, but also in terms of our research. And I think I'm a bit also worried that, as it's been mentioned before as well, AI now it's the hot new topic, and everybody wants to know about AI and wants to, do research in that space. So I'm a bit worried that there are other things in software engineering, other areas that, are important as well. So I hope that we're not all going in this kind of doing research in AI, and I see it also with papers published, at ICSE and FSE and these conferences that AI is the dominant topic, and it is an important one because it's affecting us, but we should not lose focus of other things that are just as important.
Yeah, I agree, and I guess productivity could improve, and some of the rote tasks that we do, whether it be coding or any kind of research, can be improved. But we have to be careful because I know I was talking to someone at a company, and they were concerned that if someone who maybe is not a native language speaker in whatever language they're trying to write in says, make this better. And they put it in, if that's a company secret, now that company's secret is somehow in the training data. And so we have to watch what we do as these models are being trained. And so I think that there could be, intellectual property and security and privacy implications. Like, what if a doctor puts things in, like, how do you protect that from coming out again some way. So that's a caution that, it could help productivity, but there could be some large implications to that. And so I think that balance will drive a lot of research as well. And I agree, we shouldn't all just like flock. There's lots of other things to research.
As I have tried to briefly describe in my talk, a lot of tasks that could not be effectively automated can be automated with AI or can be better automated. And that should help improve productivity. And this is, of course, the AI for software engineering part. However, it doesn't come for free. It comes at the expense of, also the impact of using AI in our systems, which challenge us in ensuring the trustworthiness of the systems we developed. And that means we then need research to somehow address the gap. Already, even with regular software, there are many things we couldn't do well, for example, with respect to verification and validation. We already had significant, for example, scalability challenges. So AI has not helped. It has just added yet another layer of challenges. But on the other hand, it's also a very powerful tool for helping developers in many different ways. And I can share my slides with you. I had a list of tasks and examples that can be effectively automated with AI and for which there aren't many effective alternatives. So there is a benefit and there is a cost. But overall, I think the benefits overcome the cost, in my opinion.
So lots of great comments have been said. I guess I think I find one aspect interesting of how we talk about AI at this conference or our large language models. It's about replacing full pieces of what, for instance, a developer does. And I don't hear as much discussion about how do we use those tools to truly augment how humans think. And so it would be really interesting to understand maybe from more cognitive psychologists who understand how our memories work, who understand how we think about facts versus synthesizing facts, and really understand where can these techniques really augment our memory capabilities because of how our brains work, as opposed to just thinking about it in terms of tasks and replacing them.
I'll just add one more thing, and it's called prompt engineering. So how do you write the best prompt to increase your chances of getting the answer you want? And so that's kind of a new thing that we'd be working with.
I mean, I don't know how it will improve our cognitive abilities, but it certainly allows us to deal with the massive amount of information we have to deal with in many ways, because that's what optimization, prediction, and all that's what it does. It helps you make the best out of that massive amount of information you have.
Yeah, I totally agree. We've been playing around with some cognitive models and looking where things can help declarative memory versus working memory, for instance. And there's an interesting thing where the machine has done so much synthesis of knowledge if you provided a prompt. Does that actually make it easier to take apart the knowledge than go and find it in the first place? And how does that actually affect the other kinds of tools that you build?
Yes.
Thank you.
Yes, hi, hello everyone. Thank you for those talks. There was comment around how humans and AI will start collaborating and how we augment humans' capabilities with AI. So in the future, we'll have these systems that are deployed to collaborate with humans, either AI systems that will interact with humans to achieve a shared goal. And then there are security problems associated with that. How do you see the testing, or how do you see that trend going in us thinking of deploying not only systems that are just independent or only AI, but actually a combination for humans to collaborate with AI to achieve shared goals? How do you see that trend going in the future, and how that's going to work?
I think that's a great question. Anyone? I think the question is asked about human and AI collaboration and how you going to test it. How can you leverage it and so on.
So as new human-machine teaming, basically to do different set of tasks, or human AI teaming, depends on the name that we want to use. How is that going to happen in the future? We need those systems that we're going to develop to be deployed as teams of AI and humans, and how that's going to be tested or developed. What do you think in the future?
Okay.
I see at least two categories, and I'm sure my colleagues can add to that. One is, of course, providing recommendations, optimal recommendation based on available information, but ultimately, especially for critical tasks with critical outcomes, the human has to be responsible of the decision. And also automating tedious tasks that do not need to be performed by any human. And I think so that the brain power of all the qualified people that we have a shortage of can be used for useful purposes and not silly tasks that can be fully automated by AI.
I'm thinking our user interfaces are going to have to get a lot better. If you think about how difficult it still is to sometimes use spell check or grammar check in Microsoft Word, we have a long way to go in order to have true shared goals, I think, with an AI agent that's with us, because we have to figure out how to do those interaction sequences between the human and the computer in a way better way than we do now.
I think that interaction goes back, and I think it was Gail who said it earlier, someone about the liability, putting the brakes on it. Was that you? Because I don't know about all of you, but when I talk to, people who are not computer scientists, just, like my daughter or my sister, they just are like all in. And I think there's a lot of businesses that could just take off without any human interaction. And people will buy those things. And so I think the liability will be the thing that causes the interaction and slows things down so that the correction can happen in the systems.
I'd just like to add something around what you were talking about. How do we truly ensure that there is a collaboration, right? And that they truly collaborate. And it is actually augmenting, the human abilities and creativity. I think that's a lot to be said about that. And in particular, what that made me think is whether we've asked these software developers, truly what they want. And we have done that to some extent. But I wonder whether we need to do it more, also kind of inspired by, again, Sarah's keynote around going to where the developers are and seeing how they're using these tools and what they need. So that's that one aspect of it, that is the co-design aspect of it, so that we don't develop the techniques in isolation and then, take them to the developers. But also what that made me think is around why ChatGPT suddenly became so popular and it's used everywhere. Automation immediately, as KPMG found out with the surveys, the developers now are using ChatGPT for different kinds of tasks, and we've been developing automated techniques in this community that have been very difficult to translate. So finding those use cases, again, which relates to my first point, how do the developers want to use these techniques? And involving the humans, this human aspect, I think, is very important.
But at this point, since ChatGPT provides very impressive results, but also erroneous results, I think I've read some of those recommendations around. At this point, ChatGPT should be used by people who can critically assess the output. If you cannot critically assess the output, you should not rely on it. I mean, that's, at this point, common sense.
They do, though.
Yeah, but, okay, people are free to do silly things. You can't prevent that.
Two cases out of the two.
Yes. And also in safety critical systems, there are many things for which AI, in particular deep learning or reinforcement learning, can help in implementing safety functionalities. You can see it in the automotive domain, detecting a pedestrian in the field of view of the car, things like that. And there aren't really reliable alternatives to AI for this. So in such context, AI brings clearly benefits. It's not perfect, obviously, but it brings clear benefits that you wouldn't have without it.
So we have time for one last question.
My biggest fear is the hype associated with not only just AI, but stuff related to it. For example, in Australia, and I'm sure it's not happening anywhere else, is that no website seems to be complete these days without a chatbot. And I generally find the chatbots totally useless for anything I want to interact with. What I worry about most is politicians deciding that AI is the latest thing that we need to deploy in circumstances where we as a community know that that's a pretty high risk step to take. So one of the things I'm wondering is in other domains, it's not uncommon for there to be conformance tests defined. Would it be possible for us to define sets of, and it would be interesting research too, to define sets of tests that in various domains the systems need to meet before they should be deployed? And to what extent are we as a community anyway not making enough use of domain knowledge? For example, we are generalists in software engineering. Nobody seriously expects an automotive engineer to go and design bridges and railway systems. And I'm wondering how much that puts us at a disadvantage in critiquing generalist solutions like these AI systems. And how do we deal with it? Can we deal with it by proposing conformance tests like FAA's flight tests for a new aircraft or something?
I agree that would be great. I think we need to bring domain experts in. I don't think as a computer scientist I could judge the accuracy of something in medicine or whatnot, but I think it would be great if governments did get involved. Isn't there like France or some country that stopped things? So I think that there's a possibility. What is it? Italy? Italy.
At some point, I don't know if it's still the case, but at some point they decided to stop the use of ChatGPT.
So governments can play a role, and I hope that there are things like conformance testing or something that slows it down if it should be slowed down.
Okay, I think this time finished now. Sorry, so we can continue discussion over lunch. Okay, let's thank our speaker again.